Hello and welcome to today's webinar, Introducing the Total Appearance Capture Scanner and Services, presented by X-Rite Pantone. My name is Bernadette Powers, and I'm a Marketing Director here at X-Rite. I will be your webinar moderator. Today we will discuss the TAC7 scanner technology and learn how it measures and stores color, texture, gloss, and some other surface characteristics of physical material samples. We're also going to provide you with a better understanding of how you could leverage X-Rite scanning service experts to help capture the appearance properties of your physical materials. Before we begin, I just want to go over a few housekeeping points. Because of the number of people that are attending today's webinar, we will keep everybody muted. During the webinar, if you have questions, please use the questions function on the GoToWebinar panel. I will be monitoring the questions and answers, and I'll be monitoring the questions, and towards the end of the webinar, we will have time for a short Q&A session. Finally, this webinar will be recorded, and you will receive a link so you can view the webinar at your convenience. With us today, we have Michelle Kay, who is our Professional Services Manager for X-Rite, supporting the Total Appearance Capture ecosystem. Hello, Michelle, and welcome.
Thanks, Bernadette. Just getting started here. All right. So as Bernadette mentioned, we are here to introduce you guys to the Total Appearance Capture Scanner and then some of the services that we also provide with it. So this is the Total Appearance Capture ecosystem. So this is relatively new for X-Rite as a business. So you guys may be familiar with some of these things, or you may not. So there's really three parts to our ecosystem. The first part is the capture. So that's talking about the TAC scanner, which is really what our focus today is going to be. We also have the communicate, and this is going to be the Pantora software in which kind of operates the TAC scanner. It communicates with a couple other systems, and we can use it for exporting and things like that. So we'll touch on this because it is integrated within our capture device, but we do plan to have other webinars that may kind of get a little bit deeper dive into this so you guys can better understand the communicate part. And then part of the system is also the compare. And that's where we're using our virtual light booth, which was a recently launched product of ours. And we already do have a webinar for this out there if you are interested to learn more, and it's called Introducing the Virtual Light Booth. So again, with that, we'll dive into the capture side of things. So this is just a short little teaser video on the things that I'm going to discuss today. So it's going to show you kind of what the physical device looks like, the scale of it, some of the other things that it's going to do. So I'll let you guys watch this and then kind of point out some of the features of it as we go through the presentation. So hopefully the video is playing smoothly for you guys right now. I know sometimes there can be a bit of a delay with webinars and these things. So this is just showing what's going on the inside of the TAC scanner right now. And then that's actually kind of the guts that we'll talk about when we get into it. Back to the inside of it. More of the features on what happens during a scan. And then, of course, talking about how it integrates with some of the other pieces of our ecosystem. And this video and some others can be found on our website. So if you want to listen to it, it does have a sound to it. We just don't like playing sound during these because it kind of adds a weird echo to it. So they are narrated if you are interested to watch this again with the narration. Okay. So jumping into TAC, before we kind of go into what the device is and how it works, it's really good to understand what it's actually measuring. So X-Rite has a history of being a company that has always measured and tracked color. And color is one aspect of what we're looking into. So right now, what we also are starting to go beyond color and into appearance. So we're going to, with the TAC scanner, be able to measure things like gloss, transparency, special effects pigments. So if you're working with anything like car paints and things like that, and they have that metallic slate or that color flop, we're actually able to capture that, where in traditional modes of photography or rendering, it makes it very difficult. And then we're also able to do things like texture, which really kind of picks up on the depth or the feel of a material. So it's not just that flat color anymore, but going into appearance. So it's also important to understand how we perceive it. So what the TAC-7 is going to do is it's going to give us the material geometry, the microsurface, and it's going to be able to capture all of that data. We're then going to use either rendering packages or our virtual light booth to look at the scene and illumination as far as what do you put your object in and how does that interact with that color and appearance. You also have your context as far as angles, how close up are you, how far away are you, and then of course the observer. What angle are they viewing it at? How do they perceive it? What does that look like to them? So capture with the TAC-7, basically it's bringing us virtual designs to life with digital material representations that are truly physically correct. So you see the kind of pile of materials that we have there. Those are all things that we've scanned through the TAC-7 scanner, and we're able to get that digital representation. So we're going from physical materials, measuring them with that TAC-7 scanner, and getting a digital output. So kind of the down and dirty process, you saw a couple things in the video as far as how the measurement looks, but on the left-hand side of this image, you see a small little square, and this is like one of our first beta units, by the way. And you have a small little square kind of put in this ring, and that ring gets put underneath that huge dome thing that has those pokey things sticking out, which are cameras. And then it takes measurements, and then that measurement is virtualized onto an object. So you can see the physical sample that was measured on the right that the hands are holding right next to that object. So we placed that exact measurement onto a basketball object, so we're seeing what does that actually look like. And we have a video that's kind of showing what that looks like within the software. So you can actually see that it's picking up the texture and those little gloss bits that you get on a physical basketball. And as you move it and move the point light, it's showing how that reacts differently. So it's not, again, just you're seeing all highlights all the time over the entire thing, because that's not how it's actually perceived. Instead, you're perceiving it as certain lights hit it and it highlights it. So you're picking up that texture, you're picking up those highlights, able to kind of move things around and see how does this really interact with that environment and with that light source. All right. So a little history of appearance and how we kind of got into it. So X-Rite has partnered with the University of Bonn, and this is over in Bonn, Germany. And they had some students that had been getting into appearance and what does that look like. And they actually originally had a pseudo with a robotic arm and a single camera, and it was kind of on, you can see you have the half semicircle here where they try to move the camera around the object and try to figure out, you know, with a single light, what does that look like interacting these two things with an arm and a movement. And that was back in 2003. And then realizing that that wasn't meeting all the requirements to get different angles, to get all the different images, they moved on to something called the Dome. And this was in 2009. And it was built with 151 Canon G9 cameras. And you can kind of maybe get an idea of how they're kind of placed around and in a full circle and from pretty much down in the bottom to the top. And then what they would do is they'd put something into a kind of conveyor belt and load it into the dome. And then they'd have multiple pictures and light sources go off at a time. So with that, the dome, it took up pretty much the size of an entire room, and it had to be completely black, completely dark. And they realized that the amount of time to go through all the pictures were sometimes a couple of days, and you could have like the cleaning crew come in, turn on a light, try to clean some stuff up, leave, and that whole measurement would just be ruined. So the idea of the dome didn't quite take off the way we had planned. Plus, you also have the idea that a lot of our customers that were interested, so the dome, you can't exactly rebuild multiples of these. So we originally thought it would be a good service to just provide measurements, but a lot of people have very super secret materials that they don't want to let out of their site. So we needed to figure out a solution to get the dome miniaturized and able to fit within an office space. So this is once again a picture of the dome, how big it is. But we took that idea and those theories of multiple cameras, multiple lights, and figured how can we make this more manageable for a business to own. So here we came up with our TAC7 device. So it's got about a 44 by 44 inch footprint, so a couple feet there. It's 71 inches high, and it weighs 278 pounds. So it's still a bit of a hefty device, but it's definitely something more manageable than taking up an entire room. So also know that it is something that can be run with standard power connection. We have Ethernet connections to an external PC, and then you can also purchase it with a backlight, which we'll talk about later. So we took something that was huge, multiple cameras, multiple light sources, and we made it much more manageable. Again, still one of our larger devices that X-Rite creates, but it's definitely worth it. So this is, if you were to, if I go back a slide, if you were to take off the top covers, and this is what's inside of it. So again, you saw this in the video. So pointing out, kind of going from the top to the bottom, the first thing that we have is a pattern projector for height map. So during the video, you saw the material having some kind of lines in it at one point where there was like black and white lines. That was trying to figure out what was the texture of the material. How deep did it go? How flat was it? So we'll project patterns on the material to try to get that information. The next thing that we have is 4 monochromatic cameras. So we went from like 100 plus cameras down to 4. So we're able to capture all of that information with just those cameras, and you can kind of see them that they're at different angles from low to high. So we're again capturing between the height map and the angles of the cameras more of that texture definition. We also have 3 spectral filter wheels, and those are going to give us the actual color. So again, the cameras themselves are monochromatic, and we're getting our color values from the filter wheels. So we're getting accurate spectral color data. And then in addition to that, we don't have, again, hundreds of lights anymore, but we were able to shrink it down to 32 white LED light luminaries. So those are all the little dots that you kind of see. My mouse doesn't like to really interact here with webinar. But you can see all those little dots with little red tails coming out of them. So those are all the 32 white LED light sources. And we're able to actually kind of get more information based off of all of this, because in addition to what you see here, underneath it, which we can't really see in this picture, but we have the sample holder, and that's actually going to rotate the material. And by rotating the material, you can get more information without having to add more cameras and things like that. We're rotating the material as opposed to the camera. So this is that sample holder that would go underneath this kind of plate that you see here. So it would kind of fit in that area between the bottom of what you guys can see and that plate where the dome rested on. So what's important to know about the sample holder is what it's capable of. So you can see in the back plate, you have these little holes. That's to make it kind of lightweight, because you can actually lift this whole sample holder out of the TAC-7 to load samples, or you can leave it in. So in the video, we showed the guys kind of pulling out a drawer and loading things while it was already in. So we can also lift it out, so if you have very stiff materials, you're not limited there. You are limited by a piece of material that is 14¼ inches high by 10¼ inches width. So anything bigger than that, as I mentioned, the sample holder will rotate. If it's bigger, it won't be able to rotate. So that's one of our limitations there. Then we actually have the measurement area. So in order to make sure that we're capturing everything that we need to capture in the right area, we have that kind of ring that goes around, and you see little symbols on that ring. And that gives us about 5½ inches diameter, so you can kind of go around that. We also have what we call our region of interest. And that's what I'm going to talk about a little bit later within the Pantora software. But just to kind of show you guys, is everything gets cropped to a square currently. So even though we can measure, 5½ inches diameter, by the time we kind of crop that down to square, it's just under 4 inches. So kind of keep that in the back of your mind when you're thinking about different materials you may need to measure. Also, the depth of the material can be up to 1 inch deep. So if you have things like stone or corian or something that has a bit of a depth to it, we can definitely measure that. You just raise the sample holder, and you kind of saw a little bit of that too in the video, where you can kind of bring it up and down with that little tab there. So it's custom, it kind of pinches it into whatever that size of that material is. So that way you're always bringing it up to the level of the ring. And finally, kind of talk a little bit about that transparency. We do have a little back plate, so if you look at the white square and the little black ring, we can replace that black ring with a transparency plate that we would swap out, and that'd be able to give us any type of material that has holes in it, like a mesh or something like that. So this is kind of that, again, overview of how that TAC sample holder looks like. So when you're, again, looking or thinking about your materials, do they meet some of these specifications? Or if not, how could you get a flat version? Could you get a smaller version cut down? What can you do? So currently we have a list of some of our supported materials. So these are things that, again, we've measured well, and gotten some good results. So we've got car paint, leather, plastic, metals, textiles, meshes. We also have an option called 3D textile, which again, if your textile has a bit of depth to it, kind of like that kind of goldish, brownish mesh underneath the brown leather there. It's got depth to it. We can measure that depth. Alcantaras, so those are things like your suede where you brush it one way and you get an appearance. So we can measure those, but understand that with Alcantaras, we don't have a magic little brush that goes in the TAC right now that will brush it the other way. So whatever way you brush it and measure, that will be the result that you get for that type of material. If anyone works, again, with like suede or anything like that, or velvet. We also can measure carpet, and then wood and stone, it just depends on some of like the repeats of it. So the top kind of material on that image to the right here, you have a small piece of stone. It's really even as far as what that pattern looks like. So we'd be able to capture that really well, picking up all those little stone flakes or colors within that stone. And we'll talk a minute about what of these materials may not work as well. So first, we do have a poll question, hoping you guys are still paying attention here. Trying to figure out what kind of materials you guys work with. So I'm going to have Bernadette kind of launch that, and we'll see what you guys, if there's anything that you currently work with, just select all the different ones, or if you don't have anything, you don't have to vote. Give you guys a couple minutes to complete that. Looks like right now we're getting a lot of people within the textiles and plastics and some metals. And car paint starting to take over. So it's interesting wow, this is just good information for us to see. But yeah, overall we've got quite a bit of you guys within textiles that you're working with, and car paint, plastics. So pretty even spread with different materials that everybody's working with. So let me pop back to my slide. And I'm back. All right. So we talked all about kind of what's supported. Some of the other things that we want to talk about are things that aren't currently supported up to a specific level. So we may be able to do and measure some of these things. However, they may not work out as well as the things that we just mentioned. So first off, one of the first rules is all materials should be flat. So again, keeping our sample holder in mind, we are going to be measuring and creating geometries and putting them on objects. So in order to do that, we have to start with something flat. If we have a curve, the TAC7 is so good, it will start to measure all of that curve, and it won't be accurate to when we put it on a piece of geometry. So if you have like a plastic part or a bumper or a mirror that has that curve to it, it absolutely should be flat. So, and again, it can be thick and flat just as long as it's no more than an inch thick. The other thing is, and this could be a good thing or a bad thing, is that we need to make sure all materials are in good condition. So you don't want this to be the material that's been passed around from department to department that has dents, scratches, or like plastics that have these little, scuffs on them, things like that. The reason being, the TAC is so good at picking up these details, you will see everything. We've even had customers that ate like a piece of fried chicken beforehand, and there was a perfect fingerprint on the plastic that he measured from that little greasy fried chicken. So you really want to make sure everything is really good, unless you're trying to like use this to see what defects are in your process, in which case measure what you have and you'll be able to pick those up and see them. So, and the TAC actually will be able to see more than our eye will see at times. So we really want to make sure that all materials are in very good condition. Even if like you folded a textile weeks ago and you didn't flatten out that fold, you'll see that itty bitty bump in one of those maps. So other things that we currently don't support are those large repeat patterns. So we showed you that the sample holder with the region of interest pretty much limits us to about 3.5, 3.75 inches. So the picture to the right, you have that big slab of granite that has all those big veins in it. We can capture a vein or a piece of it. So if you just need it for a small swatch or imagery, it'd be fine. But if you want to actually render a sheet of granite right now, that wouldn't be something we're capable of measuring. Also, when we talk about natural repeating patterns, those would be things like cheetah fur, zebra stripes, things like that where you can find it in nature. Large wood grains are another popular one. So if you're in the furniture industry, want to see what your big walnut cabinet's going to look like, you might see like that knot repeated over and over and over again. So we can do some woods really well, like a pine, but others that have more of those cathedrals, knots, unique characteristics to them, will only be able to capture a portion of it, which is fine if you're doing trim, like in an auto manufacturer, and you just have to trim out like a small part. You won't notice that, but again, if you're doing like a full cabinet, dresser, things like that, then it may not be optimal. So moving down the list, self-shadowing materials. So this would be something that had like a really big kind of, depth to it. We talk about shag carpet being a good example, where you have those really, really tall tufts. As we rotate it around, we might not fully be able to see around those tufts. Also things like human hair. You just have such fine little areas that they all kind of shadow each other. So it makes it difficult for us to capture a lot of that kind of very minute detail. Another thing we currently kind of support but don't support are layered materials. So that would be, if you think about like a tennis shoe and how that's constructed, some of them have like one color in the bottom, then there's a mesh layer, and then there might be another top layer, and all that layer is sandwiched between one material. Right now, we'd be able to kind of get some of that structure, but we wouldn't be able to get all angles of it. So the best thing would be is to contact a manufacturer that makes that sandwich material, ask for each individual layer, and we can measure that and compose it to get the best data we can. Other things are subsurface scattering materials. So it sounds a little bit complex, but one of the things that we've found are things like a rubber duck. If you think about it, it's hollow inside, and the way that the light moves around it is very complex. So right now, some of those things, again, we can measure it to a point. It just may not give us exactly the high-end results that we would get from many other materials. We also cannot do reflective materials currently. So if you think about if you're driving at night and see like the street signs, the speed signs that your headlights will reflect back, or safety equipment, if you're a runner, you have those safety vests that have the big reflective patches on it. Basically the way those work is either lights on it, you get white, or you don't. So we're not getting as much detail as we'd like from some of those. And then fluorescing materials. So those would be, again, similar to your safety vests and things like that, anything with optical brightening agents in it. We currently don't have a light source that will excite them in the TAC, but it is somewhere where we are going. So keep that in mind with like this whole list. We are aware that these are things that we currently don't support that are of high interest to a lot of potential customers out there. So we are constantly working on how we can improve a lot of these different things and how we can get there. So this is just where we're at today, so you guys are aware, but we're always going places in the future. So all the materials, once you actually have them and you want to take measurements, what you want to do is actually go through and take a measurement. So just showing you guys how simple it is this is that Pantora software I talked about that kind of communicates to the TAC device. It's really easy. You just pretty much hit that connect button. It's all tab driven. So you simply connect to your device. And then we try to make it as easy as possible. So we have on the left-hand side, when you start a job, you have your steps. So you'll see the little yellow arrow. It'll walk you through those steps as far as specifying the job, selecting your options, going through step by step so you don't get overwhelmed with that process. So again, once we do a Pantora webinar, they'll jump way more into this and give you more data. So one of the highlights that I just wanted to point out here is that on the right-hand side, we also have an area for metadata. So if you like to catalog your materials, add information as far as where they were manufactured, the date you measured it, who measured it, and you can customize this too. So if you have a specific part numbers, all that can be pretty much sunk within or synced with that material, so that way you can easily browse, search, and share. So this is just showing you some of those measurement options. So this gets into those details as far as when you're taking a measurement, what types of options do you want when you measure materials. You are selecting the characteristics of it. So we talk about the ability to measure an orange peel. So those of you guys in the paint industry, you might be aware that, you know, depending on the application of it, you can get that kind of look of an orange peel where it's kind of bumpy. We can measure that, or we can do a smooth clear coat. So if you know it was applied smoothly, we would show you it would be smooth. Again, that orange peel can add that level of realism to your renderings, though. We also have the ability to measure, you know, those flakes or the non-flakes. And as you're taking measurements, and if you have any questions as far as what something is, there's always that help available in the middle. And then there's also samples that show you, here's an example of what a car paint with flakes looks like. A little obvious, but if I go to the next one, when we start to get into some of the other materials, some of these things might not be obvious what they are. So again, you have that help menu and samples to help you figure it out. So for us, we kind of divide our measurement into either car paint, giving the options that you just saw, or you'll be given the material type options for leather, plastics, metals, textiles. So all those are like pretty much default settings. So if I went to the top of material type here and used the pull down, I could start with leather and it would auto-fill everything below of where it wanted to start with for most leathers. And then you would go through and change it according to your specific leather. So we have things like if a material is isotropic or anisotropic. Basically, does it change as you change the angle of it? So if I rotate it, am I seeing something different? A lot of textiles will be anisotropic. Measuring gloss levels from low to high. And we also have the ability to measure a clear coat. So if you're doing anything with like a varnish on it, we actually will be able to measure that varnish. So if it's got different speculars, so if I shine a light on it, will I get white reflections kind of highlights back, or are they going to be colored? So if you put a light on a gold item, you'll probably get yellow shining back. So again, you can measure those colored speculars. And then the ability to measure that Fresnel, or if I look at it at a shallow angle, am I getting a different viewpoint? So we're measuring all of these things, and you're getting that within your file. So this is an example. So once you select your material characteristics, you can select your region of interest. So in our example, our small sample Pantone chip is much smaller than that 3.5, so I would only, you can kind of see a little white lined box within that chip, and that's pretty much the area I want to measure. I wouldn't want to measure anything outside of that to include it within my file, because I just want the representation of the chip itself. If the chip wasn't there and I was measuring that white surface, I would want to make sure to avoid that little brown spot. Things like that, again, any of those scratches or dents, avoid putting within your measurement so you'll get a good outcome. And then once you select that, you will basically save the data. So for what you guys need to know about the TAC and this introduction to it is we are taking hundreds of thousands of pictures to get all of this information. So they are large file sizes. We have gigabytes, hundreds of gigabytes sometimes, of information for the raw file. But then the real cool thing about TAC is that the AXF that we have. And that AXF is going to take all of those hundreds, thousands of images and compress it into that one single AXF file format. So that's going to allow us to have something that's much more transportable. So then we go from, you know, gigabytes to maybe 10 megabytes. Something that you can actually email to somebody or easily access. So depending on your workflow, you can choose to save all that raw data, or once you create the AXF, you can throw it away. So all of this, we would either, again, as a scan service, we could manage that data for you. But if you were interested in purchasing a device, we actually have a full day of training that comes with it that we help you set up and figure out what works best for you. And then finally, once you go through the measurement, it actually will just show you the screen so you can constantly like monitor it as far as All right, once I've measured it, then it jumps down to post-processing, where it's combining all those images. How complete is it? A job log if you have any issues. Talking a little bit about the AXF file format, just to kind of introduce you guys to it. We have a lot of information, again, on our website about this, but it's describing that appearance. So it's beyond that color. It's device neutral, platform independent. It makes it that transportable file size. It supports encryption of proprietary data. It allows material certification, and it will connect those AXF files to those real-world materials and SKUs. So this is just a quick little model showing us kind of where we started with AXF in 2015 and where we're at now. So I like to just show this to show that we're always making improvements, and they come out pretty shortly after each other. So things that are supported within the AXF and things that we're measuring are just moving quickly. And for those of you guys who are using rendering applications, these are ones that currently support that native AXF import on the left. And we also have ones that will support script and map export. So if you need a normal map or something like that, we have that. So we have one more poll question asking if you guys are using currently using rendering applications. So give you guys a couple seconds to fill that out. Simple yes or no. Give you guys another couple seconds here. Okay. So kind of got about a 50-50 as far as support. So we talk about the specific export of different maps. This is a list of all the maps that we're currently working with. Again, you guys will have this webinar available to you guys, so you can review this information, pause it, look it over if you were working with specific maps and you're not sure if we're supporting them or not. Don't need to go through every one of them. But just kind of showing you a couple examples of those maps and what they would look like within our Pantora software. So again, supporting the diffuse map, normal map, roughness. If we're working again with that alpha map, talked about is it transparent or is it not? Again, we can talk about the strength of it, how transparent is it, how big are those hole openings. Here's an example of a loose weave of a linen that we've done. So again, you have that alpha map on the right-hand side showing, black is completely open, white is where the material is. So again, is it off or on? So a lot of people ask, how a material is virtualized, like how long do some of these stages take? So if you're trying to figure out, is this something for me? Is this something for somebody else to do? Measurement times can fluctuate between 6 and 90 minutes, depending on the complexity of the material. Post-processing, so that's where you're combining all of those images into that AXF file. That is highly computer dependent. If you have a wicked fast, crazy built-up computer, it could take 15 minutes. That same 15 minutes on like a standard laptop could take 24 hours. So it really depends on the computer. Also, editing, so anytime you want to edit something to tile it, that usually can take about 15 minutes, but the more you do it, the quicker you become and the faster these things go, where you just start clicking and it could take like 3 minutes. And then finally, QA. So within the light booth, the virtual light booth, you can actually look at that physical sample compared to the AXF you created and see how good is it. Did I select the right material characteristics? Oops, I selected high gloss. It probably should have been done at medium gloss because it's showing too glossy. So you would go there and then re-edit some of those things or remeasure in post-process, depending on what you wanted to fix. So those of you guys interested, possibly, you're not sure if you're ready to purchase a tax 7, if it's really for you. The benefit of the service is the fact that we obviously have all of the equipment here. we have the super fast computer, we have the location, and people that kind of will run and manage it. So all of those things, you know, you might not be ready to invest in yet. Also, depending on how many materials you work with, so if you work with, you know, 10 materials, the service might work much better than owning a device. We also have the expertise in measuring and editing all these different materials to get the best results. So we have a team that has measured probably hundreds of thousands of different things, so we know what settings work best, especially for editing. We can also give quick turnaround time, and everything's delivered to you with your specific rendering application in mind. And then we also have that access to that virtual light booth. So again, if you're not ready to get into purchasing all of those things, we have the availability of it, and we have those devices. So we have one last poll question, kind of a follow-up to what materials you work with how many do you actually work with on an annual basis? So kind of got it, again, kind of scattered around. Some of you guys are over 500, others, and then just as many are 0 to 10. So interesting information. So if you guys were interested, this is our kind of current process. So you would send materials to X-Rite to be measured, including shipping information if you would want them returned. Then you would give us the rendering application or applications that you're using. We do all the measurements, make all of the decisions for optimal results, and go through all of the editing process for you. And then we'll deliver you that AXS file to be used in your application via box link or however works best for you. So, and if you requested those materials back, we would ship them back at the end. So it's a pretty easy process to go through if you would be interested. And then part of our webinars, those of you guys still attending here, we are providing 2 free demo scans for you guys. So if you're interested in taking us up on this offer, we're going to kind of have a follow-up email on this from this webinar that'll say that, you know, thanks for attending and here's who to contact, and we'll give you those instructions on how to send those in. So we give you 2 because we want you to keep in mind, first off, all the things that I just mentioned as far as what's supported, what's not. A lot of people like to give us things that are complex. We are more than happy to try out those complex ones, but we also want to make sure that we're showing you, you know, if you do 90% of something, give us something that represents that 90%, and then give us one of those complex ones to see what that range is or how far we can go with it. So again, we are providing 2 free demo scans. So hopefully you guys will take us up on this offer and see how good they are and how they could work with your workflow. And with that,
so I think we have time for a couple questions. The first one that we have is, does your software automatically tile the scans?
So there are, depending on the material type that you have, so if it's something like a car paint will automatically tile for you. It is really cool. You basically measure, select that region of interest, and it creates something that flawlessly tiles. Other materials like a patterned type of textile, you would work within, or if you did the scan service, we would provide you with something that would tile where we would do some of the editing software to get there. So that's a good question. Again, if we have that Tantora webinar, that would be going into those details on how to get it to tile.
Okay. Next question, do you have sample AXS files that I can look at?
Yes, we do. That we can probably add a little line into our emails where to get those, because those are accessible on our website. I don't have the exact path on me right now.
Okay. Last question.
Yep.
So when sending a sample to be scanned, should I send the material I struggle with most or one that fits more into my standard workflow?
So again, that's why we are definitely going to be supporting 2, because again, we do want to see the ones that work really well with your workflow, because that's, again, what you're going to do the most of. But the ones you struggle with, again, we could be the solution for that. There is a reason that we do want to try to find out what works well and what doesn't. And you may struggle with it, and we may get 95% of the ones that you struggle with, and there's just like one little piece of it missing, but it's much better than what you would have gotten to begin with. So again, that's why we are supporting the 2 free material scans, just so we can kind of balance that out.
Okay, and we just had one more come in, so we're going to wrap up with this one. Can you scan brush metal?
Yes. Yep, brush metal is one of the ones that we can scan and we have done before.
Okay, great. So that was the last question. This officially marks the end of our webinar today. You're going to receive an email with a link to the recording so you can review the information at your convenience. So thanks everyone for joining us today and for taking the time to view our presentation. Hope you have a great day.